Hello all. Today we discuss 8255 PPI chip interfacing with 8085. Basically, first of all we design the hardware. What we're doing, first of all, this is an 8255 chip. Okay, this is an 8255 chip, and here data bus is connected D0 to D7 to 80 to 87 of 8085 microcontroller, and we use IMAP tile. Therefore, the read bar and the write bar pin are connected to the IO read bar pin and IO write bar pin to the control pin of 8085. This is 8255, and here from port A to port A07, 8 LEDs are connected in a common anode connection fashion. This is R resistance and connected to plus VAC. This is an LED. Okay. Now when this port equal to 0, then LED will be glown, and if 1, this is LED will be off. Now we on and off these LEDs after some delays. This is our logic of programming. Okay, and this is the interfacing task. This is interfacing and this is our programming. So now another pin A1 A0 is connected, and the remaining address from A7 to A2 are connected to chip select via 6 input NAND gate. Okay, so this is our basic hardware schematic. Now first of all we decode the address. So address A7 to A2 and A1 A0, and this is the selection. Depending on the address, there are various types of selection. First of all, these all are 1, because if this pin equal to 1, then output goes to 0, that is chip select of 8255. And if this is 0 0, then port A will be selected. If 0 1, then port B will be selected. If 1 0, then port C, and 1 1 means CWR. So now we partition with the 4th digit. So we see that this is F and this is C. So FC is the address of port A. Next, FD is the address of port B. Next, FE is the address of port C. Next, FF is FE is the address of controller register. So this is the controller register. Now we discuss the controller register format in a 8255, because here port A connected with 8 LEDs. So this is basically the simple input output mode. So for simple input port, D7 should be 1, D6 D5 should be 0, because this is mode 0. D4 should be 0, because port A uses output, not input. So this is used as a port A as output, and remaining all bit don't cares. Okay, why don't care? Because this is for port C higher, this is for port B mode, this is port B select, and this is port C lower. So all other bits are don't care because they are not used. So now we consider this is 1 0 0, and don't care means either 0 or 1. Anyone should be considered. I consider all are zeros. That means the address is the data format is 80. So this is the CWR data format for which this data will be sent to the CWR to initialize the internal hardware of 8255 for interfacing technique. Now we discuss about the programming code. Okay, first of all, here we discuss about our code. First of all, the first step is we initialize this algorithm. First of all, initialize CWR, okay, then send 00 hex at port A for LED ops, and then some delay will be generated. Number 4 step, send FF at port A, and then delay is generated. FF means 1, and number 6, create the loop, and this loop again is starting from here. Okay, so this is our general steps of programming. Okay, so now first of all, MVI A, 80, and it's sent to the CWR address. So what is the address? FFX. So these 2 lines of code is basically known as CWR initialize. Okay, so now next one is MJ A, 00 hex and out to port A, out FC. So this is the code, send 00 hex data to port A. Okay, now call the delay program. Delay program is written in the subroutine, call the delay program, and again we load the number FF and out FCH. So this line of code used for send FFX data to port A for LED on state, and again here we call the delay program and jump to the and create the loop, and this is the loop our program, because this is again back to the 0. Okay, so this is our program format. So now what is the delay programming? Now this is the delay programming. Here we just simply the delay programming using register pair technique. Students, you can create the different delay like a 500 millisecond, 1 second, 2 second. So depending on your delay, calculate your register value. Okay, but in this video I'll just show that the format of the delay. So this is LXI H FFF using register pair. Okay, then this is DCXH decrement, then move A, L and aura with at H until the value is 00. Here we one jump if no 0 is placed here until jump if no 0, that means until the 0 the loop starting. So here place our level. So when FFFFF decrement to 0 0 0 0 all are 0, then these loops, then jump if no 0, the loop is breaking, otherwise jump if no 0 is true. Okay, so now here we place the code return. So after returning this should be written here, and now this is the programming structure. Okay, so we all know that any delay in a microprocessor, if we will generate any delay, then this delay is depend on the clock cycle into number of T states in the loop, and n is the register values. This register value is basically this. If we changes this value, then delay will be changes. Okay, so this is the process that the different types of delay is generated to on and off state of these 8 LEDs. So after running this programming, we see that the LED will be on and off, and this process is continuous until the power off or microprocessor can be resetted. Okay, one thing should be remembered, that here in a 8255 one extra pin is available known as reset pin. This reset pin is connected to the reset out pin of a microprocessor, because when microprocessor is resetted, this reset out is activated, and also it is resetted the 8255 chip. So now this is the interfacing process of 8 LEDs in using 8255, and this is a code. Okay, so now we discuss about one more thing. These all are equal. Okay. If we consider these all are equal, okay, then just another application. The application is that now in a port B from PV0 to PV7 we connected the switch. The 8 switches are connected. Here 8 switches are connected. This is connected to plus VEC. This is switch 0, so switch 7. Okay, the 8 switch are connection. Note that if this switch is open, then there is a high voltage is created. There is 5 volt. High voltage means logic 1 volt, not very high voltage. Okay, so if the switch is pressed, then logic 0 is created. So this is a principle. The different types of switch are available in the market. So now look in this switch. This is the resistance. Now when the switch is open, here logic 1 is created, and if the switch is closed, then logic 0 is created. So this is called as pull up or push down switch. Why the name? Because when we pull this switch, the logic 1 is created. That's why it is known as pull up. And I push this switch, here logic 0 is created. That's why it is named as push down switch. Push down. Okay, so this is very, very important. Now we program that. The programming is that the LED at port A is on and off depending on the status of switch at port B. That is, if switch is closed, then if switch 0 is closed, then LED 0, first LED will be glown, and remaining all other, when switch 7 is pressed, then last LED will be glown. Okay, so now what is a CWR format? Again, what is a CWR format? This is D7 1 for simple input output. This is 2R0, D6 D5 for mode 0. This is port A control, that is 0. This is port C, that is don't care. This is port B mode, that is 0. This is port B input output, don't care. And port B is input as input, so basically this is 1, and this is port C lower, that is don't care. So what is the address? 1 0 0 0. Here I consider 0 0 1 0. So the address is 82. That is 82. So this is our CWR format to understand that the port A uses output and port B uses a right input. Okay, now we discuss our algorithm, our code algorithm. So first of all, CWR initialize. Okay, then read the switch status, then out the switch status, where at port A, and this is, and in the fourth step the loop is created, and again jump back to this, read the status switch. So now our code is, it's a very simple. Our CWR format is basically 82. Okay, should we remember that? So first of all, MBI A, 82. Now this is sent to out to FF because these are CW initialized. So these first two steps are also, this is known as CWR setup or CWR initialize. Okay, now using port B address is FCFD. So in FD, why use in FD? Because in FD is basically the read the switch status. Okay, what is the meaning of in? In means from the port FD, the value of this port, that means the value of the port B are coming into data bus. That means if any switch is placed here, then this value comes out in D0 to D7 and then stored in the accumulator. Okay, and then we out to port A, sorry. This is port A, LED port, and this is port B for read. This port should be read, and in this port we should be write. Now consider our switch 4 is placed. So what is the logic status? Switch 7 is basically 1, this one 6, 5, this 4 equal to 0, and remaining all other equal to 1. Now this value is transferred to the accumulator via this in instruction because switch 4 is placed, and the accumulator pattern is, what is the pattern? This is E0 EF. So now this EF is again transferred to the port A via out instruction. So when this EF is at port A, that means 1 1 1 0 1 1 1 1, then this LED will be glowed because here 0 is present. Okay, so here we create unconditional jump instruction from here to here because this is in an infinite loop. It's again jump to the in and then out and then in and then out. So when at any instant or any moment if any switch is pressed, then the corresponding LED will be glowed. Otherwise it will be off. Okay, so this is our some applications of 8255 using 8085 microprocessor.